Hello everyone, I'm Shao, a software engineer. And I'm so glad to be here, and this is my first time to attending OCP Summit, and also my first time public speech in English. Yeah, so it feels very exciting to do this sharing. Okay, and thank you. Okay. Today, I'd like to talk about modeling immersion cooling compatible with OCP profile. We built a tank, and we use OCP baseline hardware management profile as a blueprint. The goal is that tank can be managed by existing DCIN software without any modifications. This presentation will cover how we build a tank, how we manage the tank, and for now, what challenges we face in management. At last, we will have a demonstration video. Okay. Before sharing our experience, I'd like to draw your attention to OCP Advanced Cooling Solution. It's a sub-project of OCP Rack and Power. The member draft some immersion standard and the best practice, include immersion technology, quality and safety management and monitoring, list of requirements and the standard. And we are Wiwynn. We devoted ourselves to OCP solutions. We are pretty experienced in record scale integration. So we believe we have the ability to build a tank on our own. And where we are. Wiwynn's white paper submission on immersion standard has been approved. And Wiwynn is prototyping the use of Redfish to manage the immersion cooling tank. Okay. The picture on the right side is broaded diagram. You can see a lot of components inside the tank. We adopt two-phase immersion cooling technology. Use a low temperature evaporation to cool hot electronics and transfer the heat out of liquid. And the vapor will cool again by heat exchanger, then return back to liquid volume. High efficiency DC 48 volt power delivery system is also used in this immersion tank. For more information, we have another workshop in 2:30 p.m. Code title Service-Oriented Two-Phase Immersion Cooling with 48 volt power solution. Okay. This is our system architecture. You can see a bunch of sensors in there, like a pressure meter, moisture sensor. Their metrics are gathered by microcontrol unit. Microcontrol unit can control the valve, power, or bump based on their sensor reading. But it's not enough because the existing DCIN software can't talk to microcontroller unit directly. So we build the Redfish-based API on an industry PC that can be friendly, provide interface for existing DCIN software. So that can that you can control tank or nodes to do some action, patch some properties. Moreover, you can add automatic control logic by this interface. And the web-based GUI is convenience for service-oriented or toolless maintenance. We will show the web-based GUI in the following video. Okay. Well, we set 2 goals while modeling our tank. First is we take an OCP baseline hardware management profile as a blueprint. Want to fully compatible with OCP conventions. Second, we don't want to our output confusing existing DCIN software. We want them comprehend our data without any modification. And we got some challenges when doing this. Additional relationship between those. We found a few additional relationship between the element in a tank and additional actions. Obviously, tank need more action, like linked open or close, something like that. And different orientation. Some management software will present a rec view. And how to let rec view present a status of rec. We also will talk about it in following section. Okay. This picture is a look of our tank. And okay. This component is cartridge. Okay. This component is cartridge. Cartridge bundle 2 nodes into a tank. And there are 5 power bus bar for power delivery into each cartridge. We want to denote the relationship on refuge model so that existing design can find the related element when needed. Okay. We can use refuge model to build the hierarchy of our tank. And we use rec to represent a tank. We use enclosure to represent a power bus bar and a cartridge respectively. And we use blade and the compute system as a node. Maybe you can add the extra BNC. That will be a complete resource map. Okay. Refuge have defined some actions like boot order or system reset. But I think tank needs more additional actions like linked open or close, or when the pressure sensor is reading too high or too low, you may need to control the electric valve to balance the atmosphere, something like that. And okay. on the left side is a tank, right is a rack, right? So you can watch the animation and the image that we move the all nodes from the tank to the rack. And it's hard to see in front of the rack because they overlap. So we have to change the perspective and rotate 90 degrees to map the power bus bar to virtual chassis, like this. The red frame is power bus bar, and you can imagine it as a chassis, virtual chassis. Okay. And okay. This transformation just be friendly for some management software. They will present a topology or record view, tank view. And we use OEM attribute, location, to denote the position of the compute system in the tank. I will show a quick tour. This is our GUI. Show tank view, location information, and let's say a reading, and you can do some actions. And we also have history data.
Best choice for workload optimization and TCO.
Okay. The web-based GUI is convenience for service-oriented. Okay. Follow the above approach. We can compatible with existing design software. Like Wiwynn Cost Manager. It's developed by ourselves, and it's a smart manager for real-time management of data center. Intel ISD PODN. It's a large core architecture, enable scalable pooled resource. Zavis is a monitoring solution for IT infrastructure. Yeah. Okay. In the end, if you are interested in immersion cooling management, please work with the immersion cooling group on OCP Profile, and Wiwynn will keep following, and we are willing to contribute. And work with us to massively deploy immersion cooling to the real world data center. And appreciate everyone listen to my presentation. Thank you. Any questions or yeah.
So the liquid is water-based, or?
Liquid is a spatial water. Yeah. It's a low temperature evaporation. Yeah.
I think it's a special kind of the liquid, and the point is about
55 degree.
Yeah.
So it boils at 55 degrees.
Yeah.
And turns into gas, and then bubbles up. And
Yeah.
So it's a water mixture.
No,
No.
it's floor inert or something like that. It's a chemical that boils at 50 degrees C. Non-conductive.
The water has a special name. 那个 liquid water.
We use two kinds of liquid, 3N and solvent.
So it's low VOC though. I just was wondering about contamination of the air quality in the data center.
Air quality.
If the liquid could escape the enclosure and be in the data center environment.
No. Two-phase immersion cooling. The tank is sealed. Yeah. The gas will not be out of the
But
tank.
you showed the opening the
Oh,
top.
okay. We have a special component to leakage is very low.
Liquid is working in the closed system. So with our tank example, we open the top lid, the tank will keep the vapor in the tank. We have advanced condenser design. We will share more about this in my presentation
Yeah.
this afternoon, 2:30 p.m.
Yeah, he is our thermal engineer. Yes.
Share the design in our white paper, and we will also contribute the specification.
Thank you.
If anybody has questions on the fluid, they can stop by the 3M booth. Yeah. So we have information on the fluid at the 3M booth. Please stop by.
So you did a good job of shoehorning the existing model to do this, and I've been really impressed by it. But you mentioned that you have cartridges and tanks, and you used existing enumerations for chassis to do that. From a Redfish standpoint, we would actually like to add those to our enumerations, so you don't have to use enclosure, you can just use tank.
Okay.
And so part of the discussion here is how do you get that information or that request back to the DMPF so they can add it? So
Okay.
next time you do a schema update, right, you can just see the enumeration.
Yes,
and
yes.
the same point. This is where if you were a DMPF member, right, you could just make a submittal and say, these are the new names I want to add.
Okay.
But since a number of the OCP members are not DMPF members, I want to
Okay.
at least explain to you how you could do it, right? So there's a couple of ways. One is there's a Redfish Forum community site, which is basically it's fully open, where people can just make requests and of things that you want to go at or ask questions. So you don't need membership to do it. You can just do it. Second is the DMPF has a portal, just do submittal portal, where you can just create schema, create questions or whatever, and submit it through the portal. And the portal protects IP. It basically says, this is my suggestion. I release all IP from it, so you guys can use it freely and give it to everybody else, and it's okay. But we need that type of mechanism in order to make sure that someone doesn't get sued somehow later on because you submitted a name that somehow copyright for whatever reason. Okay, so that's what I would encourage is that Redfish doesn't want. It's encouraged by the fact that people are willing to shoehorn our names into things, but if you want a specific name, it's just an enumeration on a very large list, and we have very very frictionless adding those names. And so I would encourage you to use either one of those mechanisms.
Okay.
Or find yourself a DMTAB member.
Okay.
Have them submit it.
Yeah, we will feedback to the forum. Okay.
Okay. So thank you again for presenting and being your first presentation.
Thank you. Thank you, everyone.